Getting into the second half of Chapter 1, Lesson 2, looking at how populations change. They give us this information, and we can see in the foreground some little bunnies, right? And in the background, we can see a fox. We can see this line graph, right? So we did a double bar graph in the previous section. We talked about a single bar graph. This is a line graph because when I'm given my data and I plot it, then I just connect dot to dot in a straight consecutive order. So then it ends up making a weird, strange line. All right, so I can see at the top of that line graph changes in a rabbit population. All right, so we're measuring the rabbit population. When I read the information then, because I've got some things I've got to do and answer, but I got to know what it's talking about first. It says graphic changes of populations there at the top. Changes in a population's size can be displayed on a line graph. Figure 2 shows a graph of the changes in a rabbit population. The vertical axis identifies the number of rabbits in the population. So once again, that's the y-axis. While the horizontal axis going across, that's our x, shows time. So we have years, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? The graph represents the size of the rabbit population over a 10-year period. All right, we've got that. Then we have some things that we're going to answer. So it says we're going to interpret this data, this information that we have in the graph. In year something, the rabbit population reached its highest point. So I have to, number one, find the highest point, and that should be pretty obvious because there's only one peak or one climax to this population. Now, how do I know what year it was? Well, then, once again, we read in the directions, and we can see on the chart that the x-axis, the run line, is going to be my years. So from the highest point, I'm going to go straight down and look at what year it tells me. And it tells me it's year 4. Okay. Question 2 says, but what was the size of the rabbit population in that year? So I go back to that same point right at the top, but now I'm going to go straight across. And I notice that it's pretty much between the 800 and 900. So we would say about 850, right? That's the wrong answer. Because what we really have to do is we have to pay attention to what data in a chart is showing me and telling me. And when I turn my book sideways and look closely at the label, it tells me that it's in thousands. So it's not 850 rabbits, it's 850,000. Now that doesn't mean just add a zero, right? Because that'd be 8,500. When it's measured in thousands and I have 850 thousands, then I have to add those 3 zeros like I've shown you here. So make sure once again that if I go too fast, pause the video. If you happen to let your distracting brain take over, then rewind it and watch it so you are getting the lesson. All right, so now step 3 is going to be the more interactive part. It says, how do you think the rabbit population affected the fox population over the same 10-year period, and explain your reasoning, right? So we ought to know that rabbits are food for foxes, right? We should know that. And therefore, if I see a whole bunch of rabbits, 850,000 rabbits, then that's a whole lot of food, right? And if there's more food, as I said before, then generally that means there's going to be more foxes. Because when there's more food available, then the organism that is the predator, the one that eats it, is going to mate and reproduce because there's food to feed their babies. When the food amount goes down, then they stop reproducing, right? So when they stop reproducing, then we have fewer coming in. So one of the things we have to talk about is, it's not that a fox will mate and reproduce and the very next day they have baby foxes. So we have what's called a gestational period. And all animals are, a different amount of time. So if you have a little brother, a little sister, then you're aware that it takes about 9, 10 months, right, for the pregnancy to begin, and then you haven't up until the birth. And foxes are a little less than humans, but still, their population changes are always going to happen the year after their food population changes. So basically what that means for us, and I'm going to plot it in this orange yellow color, If we start out with we're going to say 50,000 foxes. When the population of the food goes up, right, the prey, the one that's getting eaten, and that's the rabbit, then the following year, the food or the predator will go up. So food goes up, and then the population of the foxes go up. And year after year, we're going to see as the food has a steady incline, as the rabbits have a steady incline, the prey, then the predator, the fox, is going to go up, including a gestational period, right? So a development inside of the womb. The following year, it'll go up. So it's going to be high. Now, if it starts going down, then the following year, it's going to start going down. And the less food is available, then the less the predator is going to be around. Some of them just end up starving out because there's not enough food, right? And then they die. And so the death rate would be going up instead of the birth rate. So there's just generally, when there's a predator-prey relationship like this, that it's a mirror reaction. Once the food goes up, which is the prey, then the following year, the predator goes up. Then when there's too many predators, the food is going to go down. It's going to have a great decline, and therefore, the following year, the number of predators is going to go down. And it just constantly is going to go one after the other. All right, so when we talk about page 14, then we have what's called population density. So population density is the number of the organisms, but not just that. It's divided by the area that's there. So if I take a 10-acre wood and I have 500 rabbits, then I have to take the 10 acres divided into the 500 rabbits, and that tells me about how many rabbits there are per acre. All right, so when I look at butterflies per square yard, some people have a job, and that is to count butterflies and how reproduction of the butterflies is happening in a particular area. So let's say they have 10 square yards, and in those 10 square yards, there are 20 butterflies. We have to take the 20 and divide it by 10. And when you have a calculator, you type in 20 divided by 10, you see that that is 2. So the population density would be that there are 2 butterflies per square yard. For every 1 square yard, you would find about 2 butterflies. Now, that doesn't mean that you don't have 1 square yard somewhere where there's 0 and another square yard there's 3 or 4. It just means on average, and that's what a population density is. It's an average of how many organisms of one species there are in a set amount of area. So when we look at that number of organisms divided by the area, right, then we're actually looking at fractions. We're talking about ratios, and that's going to be chapter 2 of our math book, which we'll get to here shortly in our classes. But fractions are always division, and that's how you know what type of math to do. And it's always the top number, the numerator, that is the dividend inside of the division box. The bottom number, the denominator, is the divisor. It's on the outside. I realize it's dividend and divisor, right? But I enunciate some important words there so you know which is which. Or we learn in chapter 2 that we could also just reduce, and we might see that 10 goes into both of them, and then that's going to give me 2 over 1, or which is just 2 butterflies per yard. All right, so that's how the math is done when it comes to that. All right. When we talk about the last half then, we're talking about particular things that will affect a population growth. Things that just naturally happen. Okay, so we have weather and climate, right? If we have changes in rain or changes in precipitation, you have way too much, you don't have enough, right? You can have a flood or you can have a drought. They talk about temperature changes. It gets way too hot, it gets way too cold. That's going to affect our populations, right? You have a lot of wind, You don't have much wind at all. Everything's going to be changed, right? Our population is going to be affected by these natural phenomenons in weather. So imagine what a prairie dog goes through who burrows underground when there's a whole bunch of rain and they live in a desert area. There's not a lot of precipitation, and all of a sudden they have a lot of precipitation. Their burrows end up getting filled up with water, and a lot of them will drown, right? Even the baby prairie dogs. So it's always going to affect our population. The amount of water that's available, our population of polar bears around the Arctic Circle is decreasing greatly. As you can see in this map from NASA, that in the wintertime of 1979 compared to the wintertime of 2007, how much ice is formed. A lot of our Arctic Circle is melting, and the polar bears can't travel from continent to continent hunting for food, and therefore that a lot of them are just starving to death. They're not making it. In Indiana, the past couple of springs, a lot of our berry trees, like the mulberry trees, aren't able to reproduce because once they get their flowers and stuff on, Indiana's had a freeze, and it freezes up those flower buds, and then the fruit doesn't come along. Well, that fruit not only is going to produce seeds for there to be more mulberry trees, but it's also the food for different birds. So their food supply is dwindling. When we talk about different types of weather and climate, we have tornadoes, hurricanes, tsunamis, floods, things that we can't control that is naturally going to destroy habitats. It's going to mess up the population. Tornadoes and hurricanes. So we have population changes on land. Hurricanes can change coral reefs and destroy them, and also, cause all sorts of damage on these small islands and coastal areas, all of which are habitats for living things, right? Not just animals, but also the trees. I know that Florida, they try to brace, as you can see in this picture, their trees, their palm trees, because they can't prevent the hurricanes, but they try to give the tree enough support to where it's not ripped out of the ground. Sometimes it works, sometimes it doesn't. This is an actual picture of a tsunami that took place over in Indonesia. And thousands of people lost their lives because there's no warning when a tsunami is going to happen. What ends up happening is at the bottom of the ocean, there is an earthquake, right? Or a volcano will erupt underneath the water. And all of a sudden, that energy is forced into the water towards land, and these giant waves just destroy the area. Here's another actual picture of a tsunami. And a lot of those buildings close to the ocean were just knocked over. Thousands of people died, right? The population was changed. In our area, we deal with flooding, especially if you live close to a river. There's nothing we can do about it, right? Other than try to protect our homes and raise our homes. Floods just happen, and a lot of organisms are simply going to die. Here's an area down in the New Orleans area from several years ago where a hurricane happened, and then the dam or the levee, it just burst. And this whole entire community lost their homes. But not only did they lose their homes, some people lost their lives, and a lot of living organisms lost their lives because their habitat was completely flooded. All sorts of natural disasters happen that we can't prevent. So we have wildfires. So in our country, we've had a lot of wildfires out west in California and those type of areas. We have earthquakes, and that's going to change our habitats, and that's going to change population sizes, not just of humans, but all the living organisms that live in those habitats. And we can't prevent that from happening, right? Those two bottom pictures happened because of earthquakes. One was in Canada, which is on the right, and the other one was overseas, which is on the left. Another limiting factor that we have to our population density and our population size is the idea of space, right? We only have so much land in which we can live on. So when we look at these type of countries, they don't have a lot of automobiles, so they just crowd around on any moving transportation they possibly can. It's illegal in our country to ride on a bus or a train in this fashion, those countries don't have laws against it because it's their main source of transportation to get people to and from work and to their homes. Um, but there's a lot of people in those areas. We usually have some type of lawn or yard, and it may not be very big, but these houses literally are touching each other. Some of them built on the roof of the previous one and added over, and there's just not a lot of space. This is a beach in China, and that is not what I would consider a relaxing vacation, but that's an afternoon at the ocean because there's so many people. They're just so crowded and compacted. This is an actual living, full living space in an apartment. The person was standing on their toilet. She used to teach in Sheridan and now lives in Japan. And this is considered a large, nice apartment. It's one room, right? Everything's done in the one room. You and I, we wouldn't enjoy that too much. So depending on where we are, we end up with large populations, but not just with people, with animals also, right? Sometimes we end up with areas that are overpopulated, and that's going to affect how things are, right? When there are too many deer and winter hits and they can't get to the food, then we end up with animals that are suffering and not being able to find food, and there's just too many of them in that smaller space. These saplings of these trees, they're not going to survive because they're trying to grow and take root right where the roots and the trunks are for the big trees. And when they're trying to get sunlight, they're going to be shadowed. There's not enough space for them to grow there, right? When we have trees that are tightly compacted, then other plants can't grow. And that's just the way some forests are. When we get into our biomes, we will talk about the tropical rainforest and how the large trees grow really tall with big full leaves and they soak up most of the sunlight. So down on the ground, there's not grass that grows like there is in our deciduous forests. There's not really a lot of plants that cover the ground. There's very big ferns, but that's about it because there's not enough sunlight. The space. So then when we talk about limiting factors, then food and water fits in there as some big limiting factors. Both food and water, if there's not enough to support all of the organisms in a particular ecosystem in a particular area, then the health of those organisms is going to suffer and it's going to limit how many organisms that can survive there, right? So carrying capacity is how many it can have in there um, and not cause damage to the habitat, right? If you have way too many predators, then the number of preys are going to be gone, and therefore the habitat's going to be hurt, and those predators are going to hurt. So when there's not enough water, then all organisms suffer in those particular areas. You'll see often, like in the Sahara and things like that, that there are many different organisms in the water because they all share it and they don't attack one another, right? I've seen images and videos where there are zebras and there are giraffes, but there's also lions and they're all drinking from the same water because right now they're just really thirsty and it's kind of like that middle ground where they're not going to bother one another, right? So when there is a lack of water, then that's when we have issues and organisms begin to suffer and they become dehydrated just like human beings do, and then they can't survive. Without food, then we have some major problems. And one of the problems with the Arctic Circle losing its amount of ice, the polar bears cannot travel and eat. And a lot of our polar bears have died in the past 10 years or so because they're starving to death. They are malnourished. When there's a lack of water, there's a lack of food, and there aren't any predators, there aren't any prey, then we have, over in Africa, the predators are also suffering because there's not enough food. Common to Indiana is when we've had a really dry summer and the grass dries up early, our deer in our area, they become malnourished. And when there's too many deer, that's generally when places like Turkey Run State Park opens up for a hunting just to kind of deplete the deer population so that the deers that are there have enough food, they become healthy again. Malnourished deer is just bad for the environment. So A lot of different concepts. This is a longer lesson. It's going to take multiple days. So just make sure that you have your notes and things. And then I will have the worksheet listed on Canvas for you.